Continuing with the maths, this is another, this script is outstanding. It's not mine, but I'm going to use it to demonstrate the use of mass addition and mass multiplication, and then I'll just cover what relative differences do. Not to this script, but the first two are really powerful. All credit goes to Daniel Christev on this script and every detail of it. Really nice use of pulling in a surface. Let's see if I can get it to jump here. Pulling in any surface, as you can see, and he has a really nice technique of finding out. He does a scale to it for some odd reason into a larger model, which isn't really necessary. But the main point is how he generates his points. He throws it through a really nice dimensions, division, multiplication, and integer, and the integer brings it down to floor, the counts. So basically, you end up with this really nice surface that's got squared up, kind of pretty square divisions in it. So that's just a little subtlety that's his. Otherwise, he didn't really own the script in the sense of being able to evaluate point on that script wherever you want to evaluate that point to. It moves around. He finds the distance between that point and these points. And of course, that's the data that then comes in to these wonderful scripts, which are just expression nodes of sine and cosine. He's generated them all. You can change them. You can modify these with the script. It's no problem. But in taking 1, 2, or 3, I've got multiple inputs going in, which is a great technique if you want to do renderings of transparent grounds. So if I pulled this in here, you're actually left with 3 surfaces. So if you make those 3 different transparent colors, you get some really cool structures. And the main thing about the script is no matter where you play with it, you're going to get all these incredible generated multiple layers. Now, why I bring this script up, because it's not mine, he's basically brought it into this wonderful surface, is he uses in his script the best example of mass multiplication and mass addition. So it takes those 3, and obviously multiplication is going to do kind of an average. So if I pull that in, it's going to flatten it. It's going to be not going to have it's going to be a pretty subtle surface that's informed by all that data as the result of multiplying those numbers together. Some are positive and negative, so that's why this one's pulled down. If I took this script, it's going to do the same thing. If I took that script directly, and it's going to be like that, and then the mass multiplication is going to kind of soften that a bit. Same thing with this script here. If I pull that one in, you've got 3 layers, but it's going to take those 3 layers and kind of do a mass multiplication on them. Great use of that tool. So really make use of that mass multiplication if you're dealing in functions, numbers, information. Really good tool. Let's take a look at the other one. Let's take a look at this surface, and let's put it through the mass addition. So let's mass addition is going to amplify everything. So boom, it's going to jump that up. Same thing here. This one it's going to be pretty bumpy with 3 surfaces, but it's going to add 1, 2, 3. And since they're all positive numbers, even if they're negative, they're going to add on to one another. It's going to lift that one up in the air and provide some more surface. You don't get as much hills and valleys, but you get it lifted and lofted off the surface. So there's another one. That's it, and more are made. So great use of this. That's basically what I wanted to show, was the use of functions, also taking data that's maybe comes in as multiple data and comes out as a list of lists as opposed to a list as opposed to a list of lists, and not single data. So pretty cool. And the last thing I wanted to cover, which is pretty simple, is this node. Relative differences is really easy to understand. Now to apply it, that's up to you. I'm not going to do it in this script, but basically it will compute a list of relative differences between lists, and it will take numbers, points, and vectors. So basically I brought in points, 2 points, and it says, I'll take this off. It's not too exciting to interested to end on, but as it brings it in, it's saying, okay, the difference is between those numbers 0 and 34. So looking at the first value and then the second value. So what's the relative difference? And you can just choose by dispatching which one you want. The next one is a point and a point, and I've generated 2 points from the same type of data, but I put it into the XYZ here and only in the X here. So the difference will be the 0 vector and the 0 point, and then this point of difference, relative difference. Very good information to have. And then here, vectors, it'll do that as well. So it generates the same thing, but in the form of a vector. You can tell that by the parentheses or the curly brackets around there, as opposed to, well, it's the same. That's it. Nice thing to play with, relative difference. Didn't mean to end on a low note. The main thing of this script is this jazz. Absolutely fantastic parametric control over surfaces, and this is what I use in all my worldscapes when I play with the World of Dutch Aim. and no matter where I put that, I really get the sense of control over, well, control enough that I can choose different things. Really nice. A little bit of tricks on the corners and little dips and valleys, but if you zoom into here and throw a landscape across that, or even come in from the bottom, you can have some really good skyscapes and lowscapes, and if you use multiple scapes, you can render in there. Anyhow, hope you enjoyed it.